Dear students, welcome to my channel. This is second video on part of speech tag. In this video, I am going to discuss POS ambiguity in detail and various ways to overcome this ambiguity problem. Let us start. Automated part of speech tagging problem. It is a process of assigning a POS tag to each word in an input text. Input is sentence with tokenized word, or input may be from the morphological parsing set of POS tags. Output POS tag is assigned unambiguously to each word. Now the process is not simple because of following challenges. A word may have different POS tags. For example, to sort the number, here sort is verb, and when I say bubble sort, that is sort is noun. Closed class POS tags are not ambiguous and their frequency is also limited in a statement. Generally, words with open class are more prone to multiple POS tags. Open class POS tag occur a lot more frequently and its tagging depend on its neighboring context, that is the previous and future words. See this example. Here ambiguities are present for the same word. In the first line, attack word is there, but attack having a different context. For the first time it acts as a noun, then it is verb, and after that VBP, that is for the third statement, it's act as a VBP, that is non-third person verb on a present tense. First statement is attack was brutal. King was planning to attack neighboring states, and tiger usually tigers attack their prey in a group. So here the word is same, but the part of speech tag which is assigned to that particular words are different because the context, that is the words, the set of words which follow and which comes before that words, they make the impact to change the part of speech tag of that particular word. Now see the next three statements. On Sunday I read 2 books. Now here books will be act as plural noun. During winter season he books a flight ticket to avail the discount. Here it is third person verb on present tense. They will book a flight on Sunday. Here the book will work as a verb and it will represent non-third person verb on a present tense. Now determine is very easy, but still sometimes determine comes in a different pattern. For example, I read that book several times. Here it is acts as determiner. We thought that you are in class. Here that work as a preposition. We were talking about a village group that had won the first prize in the cricket, so it becomes the which determiner, that is the in which the questions are there, so it comes under the category of which determiner. So word is same, but the part of speech tag assigned is different according to the context. Now we will see some more examples which are ambiguous for human also. Look and flies words are noun as well as verb. For example, just see the look word, look with noun tag and look as a verb tag. Look with noun tag. Her looks are keen. Here it acts as a noun. Take a quick look of a room. Again here look acts as a noun. He looks angry and she looks straight. So here the looks represent in terms of verb. So it is first is VBZ, that is third person singular, and VBT is nothing but past tense. Now see same for the fly word. Fly sometimes acts as noun and sometimes acts as a verb. For noun, flies are irritating. Candidates were dropping like flies during the technical interview. So here that flies represent noun. Next, fly as a verb tag. Kite flies swiftly in air, and insect flying over the water. So here the action is there. So here the flies acts as a verb. Each word does not have a unique part of speech tag and it might depend on the context in the word is being used. Only by seeing the context we might be able to identify what is the actual part of speech tag which is used in this context. For example, the word back has 4 part of speech tag and still word has 6 part of speech tag. Now just see the example for the back. Now the back will sometimes represent as adjective, noun, adverb and verb. Respective example, for adjective, college students prefer the back benches. For noun, there is a new restaurant at the back of our office building. For adverb, students are hesitant for going back to offline college after pandemic over. And verb, dog will bite if you back him into a corner. So here the word back, but as different context it represents a different part of speech tag. Now see the word still, and it shows the sixth part of speech tag. Still water run deep. Here still acts as an adjective. The still of late evening. The still of late evening means quiet or silence of late evening, so it acts as noun. She still lives there. It acts as an adverb. River water still by dams. Here still represent as a verb. It's past midnight but she is still doing her homework. Here it acts as a preposition. It's a small car. Still it is surprisingly spacious. It acts as a conjunctions. In English language, ambiguity with more number of POS tags, that is more than 4, is uncommon, but 2 tags are very much common. Therefore, we can't ignore. Success of the POS tagging is crucial for NLP application, in which machine have to understand language at the syntactic level. For example, applications such as machine translation, recognition, information extraction, etc. Ambiguity problem is not rare. Therefore, we have to tackle with variety types of ways. To do correct identification of part of speech tagging, only word is not sufficient, but local context is also required. That is, neighborhood information of word whose part of speech tag or POS tag is to be determined. For example, just take a simple statement, Peter saw her. Now, as a human, we can easily guess that here saw is nothing but the past tense of the see. But for machine, in lexicon or in dictionary, both words are there. So first meaning is a hand tool for cutting wood, and second is nothing but the past tense of see. But if we take the previous information, that is the before the saw, proper noun is there. So when the proper noun is followed by the verb, so it is nothing but the verb, and it is not the noun or other information. So that something resemblance is there between the future words and the previous word. Some words are unambiguous in nature. They carry only one part of speech tag. Some words are ambiguous. Probability techniques can be applied also. When we use a particular language, for example English language, we follow certain rules, such as, now these are very common rules, and generally when we write we follow, or when we speak we generally follow these rules. Two determiners rarely follow each other. For example, we never say the girl. Similarly, two base form of the word, they do not follow each other. For example, want eat is wrong, but want to eat is correct. Determiner always followed by an adjective or noun. For example, the table, handsome boy, the beautiful girl. This can be useful information that if the previous word is identified as a determine, then it is more likely that the next word will be adjective or noun. So this is nothing but what? That nothing but learning. That is, if machine learn that particular type of sequence is there, so we can do that task accurately. Distinguishing past tense, that is VBD, with past participle VBN for irregular verbs is easy because they have different forms, but some of the words having the same VBD and same VBN, so at that time we require to understand the rules. For regular verbs, remember to check the existence of auxiliary verb for whether the verb function as an adjective. For example, we want to play, that is, or we can play tennis, like that. VBN has or have plus the past participle. Whenever the past participle comes, then we use a combination of has, have plus the past participle, or be the plus past participle. Modal verbs as auxiliary verbs, could, may, should, might plus have plus VBN. So this is particular pattern is there. So it is not necessary to understand the English language in detail, but what is the main aim is that a language follows certain rules when we write or when we speak, and we require to capture that particular pattern. VBN often used as a participle adjective, whereas VBD often follow a subjective. For example, the girl talked to me, so here it is VBD, and I have forgotten my lines, so at that time it acts as a VBN. So these are nothing but some rules of English language. To automate this process, that to assign the part of speech tag for each word, the variety types of taggers are there. So this is nothing but the classification of taggers, that is called part of speech tagger. So two types are there, rule based and stochastic or statistical based. Stochastic is totally, and statistical, they are based on the probabilities. Under the stochastic, again two types are there, transformation based and probabilistic, and under the probabilistic, again generative model and discriminative model. So this is all about the classification of taggers. and we will see all this type of tagger one by one. Rule-based approach. Rule-based part of speech tagging is the oldest approach that uses the handwritten rules for tagging. Rule-based taggers depends on dictionary or lexicon to get the possible tags for each word to be tagged. So that is one of the disadvantage, because it has to take access for dictionary or lexicon every time. Some language expert will sit together to find out what are the symbol patterns. So that is very much important, and by the rules it will check the for that particular part of speech tag. Handwritten rules are used to identify the correct tag when a word has more than one possible tag. Disambiguation is done by analyzing the linguistic feature of the word, its preceding word and following the word, and the other aspect. So here rule is applied, and according to rule that disambiguation is done. For example, if the preceding word is article, then the word in the question must be noun. This information is coded in the form of rules. The rules make context pattern rules, or as regular expression, compiled into the finite state automata that are intersected with lexical ambiguous sentence presentation. So this is nothing but what implementation part. So we can write down the rules in terms of regular expression also. Tagit, the first rule-based tagger, uses context pattern rules. Tagit used a set of 71 tags and 3300 disambiguation rules. These rules disambiguated the 77% of the words in the million word Brown University corpus. So Brown University corpus, so they check on Brown University corpus, so success rate is 77%. For example, I want to read a book. Here book can be noun or verb. Rule, before book determiner is there, therefore it is a noun. So in this way they just made the rules, that is 3300 disambiguation rules, and based on that they check the pattern and they access the lexicon every time, and they assign the part of speech tag to that particular word. Limitation of rule-based approach. Hard-coded rules are required. Rules has to be updated based on language change. It needs to check lexicon every time, which is not efficient approach. Strong language expert team is required to write down that detailed rules, because we are not considering only for English language, because for NLP is nothing but for natural language processing. So we require that subject expert for that language to make the part of speech tagging in an accurate way. Second type is stochastic or statistical based approach. It is based on concept of probability and machine learning. Training and test corpus are required. Two approaches are there. First is transformation based tagger, and second is probabilistic based tagger. Transformation based tagger. This tagger is based on concept of transformation based learning approach. So TBL learning approach is used. TBL uses supervised learning. That's why there is need to use the training data set. There is assumption of pre-tagged training corpus. It combines the idea of the rule-based tagger and stochastic taggers. Like the rule-based taggers, TBL is based on the rules that specify what tags should be assigned to that particular words. But like the stochastic tagger, TBL is machine learning technique in which rules are automatically induced from the data. So when we see the example, you will come to know these last two points. That is, initially it acts as a rule-based tagger, and after that it will learn that particular pattern. Label the training set with most frequent tags. Now for example, see the can was rusted. Now initially the is assigned as a determiner. Can be modal verb, but here can is noun, but it assigned first can as a modal verb. Was is past tense, and rusted is also past tense. Add transformation rules to reduce the training mistake. Now we require to make the changes that here can is not modal verb, it is a noun. So we require to make the change that MD to NN, and here was is okay, but rusted is here. By default it assigned the VBD, but when initially before the rusted was is there, so it should be of VBN, that is the past participle. See the explanation that how that probability based tagger works. Explanation: can be noun as well as modal verb also, because can has that this ambiguity that it can act as noun as well as it can act as a modal verb. It uses machine learning as well as grammar rule. Modal verb is never preceded by determiner. Here the can is coming, So modal verb is never preceded by the determiner. Also in corpus, possibility of determinal modal verb pair is 0. So this is very important. Even in the rule it is there that before the modal verb it is never preceded by the determiner. Also when they are seeing that particular corpus, for example brown corpus, at that time the pair of in training data set, the pair like determinal modal verb will be 0. Therefore it can be replaced by the noun tag. Now for the rusted. Rusted can be VBD as well as VBN also, because it is a regular, it is not of irregular, it is a regular verb. So its past participle and past tense is same. Now in grammar rule, VBN is preceded by VBD. Also in corpus, possibility of VBD pair is negligible, because when VBD is there, for example was, after that always there is a past participle, so it is replaced by VBD. Also in the corpus, the pair that VBD is negligible, so we are getting a very less probability for that particular combination. So in this way it is using the technique of handwritten rule, as well as it will searching the pattern in that particular training database, and it is using the probability of that particular pair, and based on the rule and the probability of that particular pair, it assigns the part of speech tag, or it assigns the final part of speech tag. Now see the next example. Here the statement is expected to race tomorrow. Now race here can be used as noun also and can be used as a verb also. Now see the first statement, is expected to race tomorrow. Now to race means it acts as a verb only, and here it is assigned. For example, when race is preceded by to means it should be verb, but it is assigned as noun. So this is nothing but the wrong. In the second case, this race is corrected by tag as noun. So in the second statement it is corrected that in the second case there is a race correctly tagged as noun. Now see the second statement, the race for outer space. So when the statement is the race for outer space, here the race is not preceded by to, and therefore it acts as noun. So here it is correctly identified that race is noun, but in the first statement it is incorrectly classified as it is a noun, but here it acts as a verb. So this is a mistake here. Now see, for example in brown corpus, the race is most likely to be noun. What happens when they check the brown campus? So in the brown corpus, the probability of race giving the noun is 0.98, and the probability of race giving the VB is 0.02. What it indicates that in the brown corpus, the probability that the word is race word is coming with as a noun tag is 0.98. Means almost in brown corpus, whenever the race word comes, it comes with noun tag only. So that is very high, that is 0.98. And when the word is coming as a race which acts as a verb is very less, so it is only 0.02. Therefore race is labeled as noun because its occurrence is more. Now Brill tagger learn a rule that applies exactly to this mistagging of the race. Now how the Brill tagger, or based on the stochastic and probability it works, it will change for the first statement, it will change NN to VB when the previous tag is to, because here the race is preceded by the to word. So when the particular word is preceded by to, it means it indicates a verb. So it changed the NN to the VB when the previous tag is to. This rule would change race to race VB in exactly the following situation, since it is preceded by to. So in this way the stochastic tagger will work. Now the last point is probabilistic tagger. Approach is to pick the most likely tag for this world. Two approaches are there, whether you generate the data from the class or class from the data. Now I will explain with the example. This is somewhat difficult or confusing statement, whether you generate the data from the class or class from the data. Problem statement, data available of the form D and C. Now here C is for class and D is your data, where D is observation and C is your hidden classes. Two types of model are there, generative model and discriminative model. Now generative model, the examples of generative model are hidden Markov model and naive Bayes classifier. Now when part of speech tag is done by the hidden Markov model, so at that time we are using the combination of naive Bayes as well as the Markov property. Now these are nothing but the generative model. Now here from the diagram we can see that class generates this particular data. Now the arrow is going downwards. Now here class is generating the data. In generative model we assume that class is there and it generates the data. For example, class is given. Now for example, class is your any subject name and the data is nothing but all words are generated from that subject. So if subject is maths, so words generated from that subjects are nothing but integration, derivative, absolute difference, formulas. That is nothing but what? It is data of that particular subject. Now here we are going downward side. Part of speech tagging are there and words are generated from that. Now here part of speech tag is nothing but our classes. So for example, part of speech tag noun. So noun is our class and from that noun we generate the variety types of word. For example, girl, table, key, boy, then bed, all that words, they are belong to the category of noun and they are generated from which class? That is nothing but the noun class. So arrow is downwards, that is the class generates the data or observation. So here in generative model for part of speech tag problem, what is mean by the classes? So all types of tags are nothing but the classes and for every class there is a few set of words are there. Here flow is downward. This is very important to remember. Here flow is downward. Now see in detail. For example, the statement is the girl is intelligent. Now what is our problem? We have to assign the part of speech tag to this particular statement or for every word of this statement. The girl is intelligent. Now here the four classes are there. For example, determiner class, noun class, verb class and adjective class. And these are the classes and they are generating this data. The data, the girl is an intelligent. Now arrow is downward. Now when we are using the hidden Markov model, at that time what we are deciding? We are deciding the part of speech tag for the. So here we are deciding that based on our state transition probability and emission probability. For example, when we want to decide the part of speech tag for the girl word, at that time we will take what is the probability that girl is acts or girl, or in our training set how many times girls appear as noun, and we will check also the state transition, that is when the girl or when that particular noun comes, before that how many times determiner comes. So that is nothing but what? State transition probability, and this girl is comes from the noun class, that is nothing but what? Emission probability. So when we do the part of speech tagging using the hidden Markov model, at that time we are considering these two probabilities, that is emission probability and state transition probability. Now in the next video I am going to explain the hidden Markov model in detail, where we are using the generative model, that is hidden Markov model, to do the part of speech tag. For example, POS tags noun classes generates the data like girl, boy, man, woman. I have just explained this. Statement is the girl is intelligent. In this case, determiner class generates the, NN class generates girl, VBZ generates is, and JJ generates the adjective. Now discriminative model. Discriminative model is exactly opposite. Arrow is upward, and here data identifies the hidden class. In the discriminative model, data is there and you assume that hidden state is generated from the data. Here flow is upward, that is data identifies the class. For example, keyword of the subjects are given and from the keywords we determine that subject. For here exactly opposite. For example, integration, derivative, absolute difference and various formulas are given, and based on that keywords we identify that hidden class is nothing but maths. So like that, keywords are data and subject is class. Class is hidden. By seeing the nature of data we can assign the probability of the particular class. Maximum entropy model and conditional random field, these are again two techniques to assign the part of speech tag to the statement automatically, and these two techniques, that is maximum entropy model and conditional random field, they are using the approach of discriminative model. Now how the discriminative model works takes place. Now the process is different. The girl is intelligent, and after that we will determine the part of speech tag for each word. Now here how the process takes place. Here we require the features. So for every word various features are given with respect to previous word and future words. So when we solve the problem on this topic also, at that time you will come to know that when we solve the problem, at that time lot of features are given, and various features are given with respect to previous words and future words, and from that features we can decide the POS tag for that particular word. That is, flow is upward, because when we determine the part of speech tag for this girl word, at that time the preceding words are the and the next following words are is intelligent, so they are having a particular features and particular relationship is there, and based on that we decide that girl is belongs to which class, noun. So that's why the flow is upward. From that features we can decide the POS tag for that word. That is, flow is upward. For a given word, using the features of neighboring words we can determine the class or part of speech tag. So this is nothing but all about the detailed information about the tagger. So this diagram is very much important, that how the part of speech tagging takes place in NLP. Now in the next lecture or in the next video, I am going my planning is to make a video on generative model, that is part of speech tagging by the hidden Markov model, and after that discriminative model, that is nothing but upward flow, and conditional random field and maximum entropy model are the example of the discriminative model. So this is all about the part of speech tag ambiguity problem and the variety types of ways how to overcome this problem. These are the references. Thank you.